Welcome to the first part of our demonstration of AVID PAGE. PAGE stands for Parametric Aircraft Geometry Engine, and it's basically a tool meant for aircraft designers to be able to put together geometries fairly quickly without having to deal with the intricacies of CAD. You should note that PAGE is not meant to replace CAD, but instead you can create these geometries in PAGE and then export it out to CAD to add more detail. Now in this first part, we will be looking at the basic features of PAGE and show you how easy it is to put together geometry fairly quickly in PAGE. In the second part, we will be showing you the more advanced features such as grouping components and also the mass properties tool. Now I have AVID PAGE open here, and as you can see we have a model of an F-18 and this is fairly detailed model of an F-18 geometry, considering that it didn't take us very long to put it together. So I'll just kind of show you how easy it is to put together geometry such as this. The model that we will be creating today will be one of the Predator UAV that looks something like this. So let's just start, and I'll start by with a clean sheet of paper, and in the front here, in the middle, I should say, is the rendering window, and that's where all the geometries are rendered. We can render it in solid mode, transparent mode, or wireframe mode if you'd like. Now over on the left hand side and the right hand side are the dialog boxes that I can undock and redock if we'd like, and that controls all the parameters and the components that we're going to add, and you'll see that in a minute. But we can undock and redock them so that you can customize your space in any way you like based on how you work. So let's just start by adding a fuselage right now. So all I have to do is just go over to this available components, select the fuselage, and drag it into the rendering window, and a fuselage shows up. You can see, although it's solid mode, it's kind of faceted, and that's because of how it is being rendered. I can increase the number of points per cross section over here in the components properties, and as you can see, as I increase that number, the geometry looks more and more smooth. Now we need to note that although it's faceted in the rendering window, the geometries are still described as NURB surfaces, so they're always described as smooth surfaces. Instead of using this rendering method, which is the polygon method, I can change it to a B-spline method by just going to the preferences and changing it to a B-spline. In terms of in the B-spline rendering, everything is smooth because it's smoothed out by B-spline curves. The difference between B-spline and polygon is just how the geometry is rendered in front of you in the rendering window. B-splines usually take a little bit more graphics computational power, while polygons don't take as much graphics computational power. So anyway, so we have a fuselage right here, and some of the parameters that I can change is its location, so I can move it in X using the slider bar here on the right hand side of the components property, or Y location, or I can just kind of type that in, and all our parameters that describe the geometry have that same feel. It would have a slider bar and also a place where you can type numbers in. Some of the shape parameters that's available to you for the fuselage is the nose length and some angles, also for the midsection and the after body. Now I need to change the length of the nose here to about 8, so I'm going to use just the slider bar and then just move that to a value of 8. And let's move that into the center here, and I'm going to use my scroll button mouse wheel to zoom in and zoom out. So as you can see, I've just changed the length of the nose. I need to change the cross section so that it looks a little bit closer to what a Predator UAV nose would look like. So I'm going to just click on one of the cross sections over here, and this cross section is the cross section between the nose and the midsection. And to change the cross-section shape is just as easy as selecting that cross-section, grabbing on to the control point over here, and I can, as I move the control points, you can see that the 2D section changes and also the 3D section changes in relation to what I do. Now, the elliptical cross section doesn't give us very much detail, so I can change to a conic cross section. And the conic cross section is described by points, control points. I can either change the numbers in this table of these control points, or just grab the control point. So again, I can grab, say, P1. As you can see, moving these control points basically changes the cross section. Now I need P1 to be at 4, and that's greater than the extent of my 2D window, so I'm going to type that in. So I'm going to type that in to 4.0, and I need a P3, which is the side here, to be about 3, and I think I can drag that. Yes, so I'm going to drag that to about 3. And I'm going to move these control points, P2 up here and P4 over here. So as you can see, as I change the geometry in 2D, the 3D geometry changes too. So there you have it, one of the cross sections over here, and it's described in 2D and also 3D. I need to change the next cross section, which is the section between the midsection and the afterbody. So I'm going to click that one, and I'm going to change P1 or move P1 to about 2.5. So I'm going to grab the control point and just move it up. Again, you see the geometry changed, 2D geometry changed together with the 3D, and P3 at about 2.5 also. So right about there. I'll move P4, which are our weighting control points, and just change the weight of P2. All right, the last cross section is is at the afterbody, and since the points are clustered together too much, I'm just going to type it in. So P1 should be about, excuse me, sorry, I just changed the view. I'm going to change it back to single view. So P1 should be at 2.0 and P3 at 2.0. Okay, I'm going to grab P2 and also P4 and adjust its weights over here. So let's move the geometry over here. The last thing I need to do is change the afterbody length to extend that out. So I'm going to go back to the shape parameters, and remember these can be changed easily by just moving the slider bar or typing it in. I'm going to type it in and change the afterbody length to 16, and that just moves the afterbody length over there. And I'm going to use my mouse scroll to kind of zoom in and zoom out. So there you have it, very quickly, a rendition at least of a Predator UAV fuselage. The next thing we need to do is basically add wings. So I'm going to select the wings and just double click on this wing pair over here, and it shows up. I'm going to zoom in, and there you have a wing. I'm going to turn off the axis so that we don't see the axis obscuring the wing. And the shape parameters of the wing include include span, root chord, tip chord, dihedral, aspect ratio, taper ratio, area. You notice that the span, root chord, and tip chord is grayed out, and that's because we've selected to use the aspect ratio, taper ratio, area grouping independent parameters to change. I can change that and specify any grouping I want, and the other parameters that are related to it will be grayed out but automatically calculated for you. Now I'm going to just stick with the default, which is the aspect ratio, taper ratio, area grouping. And for the wing, I need an aspect ratio of 19.25. So I'm going to type 19.25 there, and the wing changes as I make the changes in this dialog box. The taper ratio at 0.6 is correct, and let's just change the area to 123.2. Again, I can use the sliders if I need to, or I can type the numbers in. And I'm going to zoom out in this case just to show you the wing rendered here. The wing also has a dihedral of about 2 degrees, so I'm going to type that in. There you have it. Now we can change the cross sections of this wing, and if I click on the cross section tab and click this cross section over here, this is the cross section at the tip. You see in the 2D window there's a cross section of an airfoil and the profile, and I can select different airfoil profiles and adjust its settings to get what I want. In this case, I'm just going to stick with the NECA 4-digit airfoil section, and I can change the thickness to chord ratio. And as you can see, let me zoom in here. As I change the thickness to chord ratio, the 2D section changes, and so also the 3D section. So in this case, I'm going to bring it down to about 9%, and so that's the cross section of the tip. The last thing we need to do is just to move the wing to its correct location. So I'm going to just move this X location over here, and I'm going to move that to about 16. So, and I'm going to move the Z location down to negative 0.4 so that it is low on the fuselage. And let's change this to 16 as a whole number, and move the geometry. So very quickly, I've just made a fuselage and a wing. I can also rename these components over here on my left. So these on my left in this vehicle dialog box, let me open that out, are all the components that's installed. And I'm going to rename this wing the main wing. So I'm just calling that main wing, and it helps with organization of these components. So as you can see, fairly quickly I can put together geometries in AVID Page. Now this ends the first part of our demonstration. In the second part of the demonstration, I'll show you some advanced features where we'll add the tails together, tails and group them together. I'll show you how to make a propeller fairly quickly, and also how you can calculate the mass properties for each of the individual components, and also group wise. Before I end the first part here, I just would like to also say that AVID Page is a cross-platform compatible program, so we support AVID Page in Linux, Mac OS X, and also Windows. So hope to see you in the second part of the page demonstration.